So now I got extrapolation up and running. So here is the same graph as before. I can move my finger across here and you can see the signals changing there. And below that one I have the extrapolation graph. So when I push my finger through the sensor range, you can see that the blue line, which would be the center of the object, so around here a bit, and it is actually tracking quite nice, as it just has 3 sensors to base its input on. So when I'm taking the finger and going here back and forth, the line here goes back and forth. And also the height of that red line here says how large the obstacle is, or the enemy. So when the line is generally high, I have a high probability that it is actually the enemy. So if it's just a small sensor, maybe it can be noise or something, and I should not do anything about it. So it also calculates the probability of an enemy. And it's actually working really nice. And like from this data, the blue line is very easy to see the angle of the enemy. Try to do that from this data, it would be quite much harder. But now those algorithms are running on the computer. Some of them will be running on this processor on the sensor board, and some of those algorithms will be running on the main CPU. So like I have a main processor in here, and I have one processor for those sensors, and one processor for those sensors, and one processor for the sensors on each side, and then one processor for on the ultrasonic sensor. So it's 1, 2, 3, 4, 5, 6, and then the central processors. It's 7 processors on this robot. But I believe it's gonna be needed because it's about 100 I/O or no more than 100 I/O that's required, and quite a bit of processing power. Yeah, so that's how far I've gotten right now. And this algorithm for calculating this data, I have not developed myself. It is borrowed from Benjamin Wedde.